Welcome to EDU World Space.
In problem 16, we're told we have a tank with a mirror at the bottom, and the tank is filled with water to a depth of 20 centimeters. So this blue line is the water line, the water-air interface. And we have a small fish that is floating motionless 7 centimeters below the water's surface. So this green line here is my fish, and it's 7 centimeters below the water. And in part A of the problem, we're asked to find the apparent depth of the fish when viewed at normal incidence. So at normal incidence, you're looking straight down here. So basically what's happening, there's light coming from the fish to your eyes, which enables you to see it, but the fish is in water and your eyes are in air. And so that will make the fish appear at a different distance than its actual distance, because the light is traveling through two different media with different indices of refraction. So the way we'll solve this problem is to use equation 34.13. And this is the equation for a plane mirror. So with when you are in two different medium. So we have NA, which is the index of refraction of medium A over S, plus NB over S primed. And actually I mislabeled my A and B in the figures here. So actually that should be B and this is A. Okay, so Na is water and Nb is air. And that's equal to 0. And so we know Na, we know Nb, we know S. So S is the object distance and S prime is the apparent distance. So we know that the object distance is 7 centimeters. So the idea is to find S prime, and we can just rearrange this equation a little bit, where we now have NB over S prime is equal to minus NA over S. And if you do a little bit of shuffling around, you'll find that S prime is equal to minus NB over NA times S. And we're given NB, we're given NA, and we're given S. So it's just a matter of plugging in the numbers. So we know that NB is 1. That's the index of refraction of air. And NA is 1.33, which is the index of refraction of water. And this is multiplied by the object distance, the actual distance of the object, which is 7 centimeters. And when you plug this in your calculator, you find that it's 5.26 centimeters. Okay, so minus 5.26 centimeters. And so this equation will be the main equation for this problem. So we'll utilize it again in part B, because in part B, we're asked now, what is the apparent depth of the image of the fish when viewed at normal incidence? So the image of the fish is the image of the fish that's formed when it's reflected from this mirror. So now it'll have some other apparent depth. So remember, for a plane mirror, when you have an image and it's at normal incidence like this, you would find that the object distance is also equally spaced from the mirror, right? So if I have the perpendicular line to this mirror surface and I draw another perpendicular line, then the fish would be the same distance away as the object is from the mirror. So we have the image distance and object distance are the same. And how do we find out what the image distance is? Well, we can easily find the object distance which is the difference of these two numbers, right? So that's the space that's remaining here. So that's 20 minus 7, which is 13 centimeters. Therefore, the image distance is also 13 centimeters. And the total distance at which the fish would appear from the surface of the water is the depth of the tank plus the distance of the image from the bottom of the tank where the mirror is, right? So we just add 20 and 13, and that will give us the total, which we obtain as 33 centimeters. So the fish's image is 33 centimeters below the waterline. So that is actually now our new S, right? So if we were to plug into this equation, we have S is equal to minus S prime is equal to minus NB over NA times S, and our new S is 33 centimeters. So that means that S prime is minus 1 over 1.33 times 33 centimeters, which gives us minus 24.8 centimeters.